Hi guys, in this experiment we will see about the OCC and load characteristics of separately excited DC shunt generator. So the circuit diagram is this. The nameplate details for motor is this one, and for generator is this. So the objectives of this experiment is to find the generated voltage of a separately excited DC generator for different field currents by open circuit test, and to find the armature resistance RA, and finally to determine internal external characteristics of given DC generator by conducting load test. The apparatus required will be ammeter, voltmeter and rheostat in the corresponding ranges, and tachometer, DPST switch and SPST switch, loading rheostat with this quantity. Okay, before going to the procedure, the precautions we should take care is that the motor field rheostat should be kept at the minimum position at the time of starting. The generator field rheostat should be kept at the maximum position at the time of starting. The DPST switch is uh, kept open during the OCC test. The SPST switch is opened at the starting to note the residual voltage. So the procedure for the OCC test is uh, by closing the DPST switch and using the 3-point starter, the motor is started. The motor field rheostat is adjusted and the rated speed is set. The residual voltage is noted down from the voltmeter and the SPST switch is closed. The generator field rheostat is varied and the generated voltage Eg and corresponding field current If are noted. The same procedure is repeated up to the rated voltage. After noting down all the values, this is the tabular column for the open circuit characteristics test of DC shunt generator. Next, we will move on to the load test. For load test, the DPST switch 2 is closed when the rated voltage is reached. Then the load is applied using loading rheostat and the load current IL, load voltage VL and field current IF are noted down for various load current. The same procedure is repeated up to the rated current. Okay, the tabular column for the load test on DC shunt generator is this one. Here it is a field current and load voltage and the current with the current from the armature, and finally Eg value. Eg is equal to VL plus IARA. For this we have to substitute these values and we have to find the Eg values. So with these two with this two tabular column, we should draw a graph. We should draw two graphs. One is for OCC characteristics and other is for load characteristics. For OCC characteristics, we should draw a graph between Eg and field current, and for load characteristics, for the y-axis will be Eg is Vg by VL, and x-axis will be VL. So the graph for load characteristics will be like this one. So this is Eg versus Ia internal characteristics and VL versus IL external characteristics, and the current in x-axis current IL by Ia, and in y-axis Eg VL in volts. For OCC characteristics, y-axis will be Eg volts and x-axis will be field current. So the residual voltage you can see here, right? Okay, this is the residual voltage and the graph will look like this. With this the experiment is over, but if you wish to see some questions for Viva, you can take a screenshot of this or you can just watch it. Okay, thanks for watching this video.